Question 1. Explain the meaning of differentiation. Well, differentiation is a fundamental mathematical operation in calculus that measures how a dependent variable changes relative to an independent variable. So for question B, please explain briefly 6 common techniques of differentiation. Well, the first one is power rule. Power rule used to differentiate functions whereas variable is raised to a constant power, which you can bring the exponent to the front as a multiplier and subtract 1 from the origin, such as the example that given d over dx x multiplied with x power with n equals to nx power with n minus 1. So for the second, product rule. It is used when a function is a product of two distinct simpler functions, let ux and vx. Example, d over dx multiplied with uv equals to u multiplied with dv over dx plus v multiplied with du over dx. And the next one is quotient rule. It is used when a function is division of two simpler functions where the denominator is not zero, as like the example that I given. Okay, for the next is chain rule, where it is used to differentiate composite functions, a function inside another function like f g x. There we can differentiate the outer function while keeping the inner function intact, which is it can multiply it by the derivative of the inner function, like the image I gave below. Okay, for the fifth, implicit differentiation, where used when a function cannot be easily solved explicitly for y in terms of x. You differentiate both sides of the equation with respect to x, which will apply to the chain rule to the terms containing y, and then it will solve for dy dx in algebra. And number 6, it is logarithmic differentiation. It is used for highly complex algebraic expression which will involve multiple products, quotients, or power, it is a function where both the base and exponent contain variables. We can take logarithm ln of both sides first in order to simplify the expression by using log properties before differentiation. Okay, for the question 4, the problem statement is use the linear approximation to estimate the value of 4 multiplied with 8.99 square minus square root 8.99 and correct to 2 decimal places. For the first step, we will define the function fx by looking at the expression, and then we use the fx equals to 4x squared minus square root x and simplify it as 4x squared minus x power 1 over 2. We want to estimate the value of this function at x equals to 8.99. For the next step, we will choose a value a close to 8.99 that make calculation more easier. So we will let a equals to 9 and find the difference, which is x minus a equals to 8.99 minus 9, which will equals to negative 0.01. Next step, we will substitute the a into the original function, which is f9 equals to 4 multiplied with 9 square minus square root 9, which will be the final answer is 331. And then we will differentiate fx to the x, which is d over dx 4x squared minus x power x 1 over 2 will be equals to 8x minus 1 over 2x power with negative 1 over 2, and more simplify it is equal to 8x minus 1 over 2 square root x. And now we will evaluate the derivative at a equals 9, which we will substitute the 9 to the answer, and we will get the final answer, which is 71.833. And for the final step, we will use the linear approximation formula and we will substitute our known values into the formula, which will 331 plus 431 over 6 and multiply with negative 0.01. and we will get the final answer for it, which is 320.28167. So in order to correct two decimal places, the estimated value is 320.28.
Okay, so for question 2, we got to find the dy over dx for the following function. For the question 1, we got y equals to 4x cubed times sec 7 minus 3x. So for this question, we have to use the product rule, which is d over dx, u times v equals to u prime times v plus u times v prime. So in the original equation, it shows u is in the front and v is in the back. So in this case, the u will be this one, and the v will be this one. Okay, for the u, we derive it like as usual, and we got 12x square. And for the v, we have to use the chain rule because it has two parts. And for the simpler reason, I decide to let gx take this place, or 7 minus 3, to make it easier. And we derive it using a chain rule here. So we got sec gx times gx times g prime x. This is happen because if we derive sec, it's become sec of times tan, sec theta times tan, and we derive the gx here, put it in back here, and then we take the gx, which is 7 minus 3x, substitute it into the gx when we got sec times 7 minus 3gx times tan 7 minus 3gx times negative 3, and we simplify it, and we get negative 3 sec times 7 minus 3x times tan 7 minus 3x. And then we got to assemble it using the product rule, which is in the earlier I show, which is u prime times v plus u times v prime, and we take those all that we calculate before and just substitute it into this one. Okay, after we substitute all the v prime, u prime, v, u and v prime, we have this one long monstrosity, this one, and we can simplify it by making it to 12x square times sec 7 minus 3x minus 12x cubed sec times sec 7 minus 3x and times tan 7 minus 3x. So we can simplify it furthermore because this one and this one is one unknown, and we can factorize it, and it became 12x cubed 12x square times sec 7 minus 3x times 1 minus x times tan 7 minus 3x. That's all for the question A, and we move on for question B. We got to move on to the question B, which is y equals to exponent to of 2x plus 2x over cos 4x minus 3, which is over here. We have to use, for this question, we have to use quotient rule, which is d over dx times d over dx u over v equals to u prime times v minus u times v prime over v square. like usual, we have to determine which is u and which is v. For this case, the top one is going to be u and the bottom one is going to be v. Obviously, we have to derive both of that to get v and u prime, which is for right here we have, I already derive it into the u prime, which is 2 times exponent the power of 2x plus 2. So right here we have v equals to cos 4x minus 3, and I derive it become to get the v prime, which is negative 4 since 4 times 4x. The why it became negative sin, because if we derive cos, it will become negative sins. And then if after we got both of v prime and u prime, we just assemble using the quotient rule, which is right here. We got u prime, which is 2 exponent the power of 2x plus 2 times by regular v, which is cos 4x minus 4, and it will be minus with the regular u, which is exponent the power of 2x plus 2, and it's time with the v prime, which is negative 4 sin 4x, and will be divided by the v square, which is cos 4x minus 3 and minus 3, and is going to be squared. So we just simplify the numerator right here to make it more pressurized to loop, which is going to be right here, the 2 exponent 2x plus 2 and the times cos 4x negative 4 and 4x minus 3 plus 4 sin 4x times exponent the power of 2x plus 2, which is, we just turn this take this the back one to the forward one to get this look more pressurized to look at. Actually, this part is already the answer. This part is already the answer, but yeah, that's all for me. Thank you.
Hi, my name is Uzay Hakim bin Muhammad Kamal Hakim. My student ID is 2025X79214. So today I'm gonna answer the question 3 that's given to our team. The question 3 state that given e power of y power of 2 minus 2 plus sine 2x plus 5x equals to x power of 2 ln 3 plus 4y minus 2y. Find dy dx using implicit differentiation. So the first thing that we are going to do is we need to write the equation first. So the first thing that we're going to do is we need to differentiate them one by one. The way to differentiate the e power of 2 minus 2, we need to use the chain rule. First, we get the power out first. Y, we need to differentiate them first. 2 equals to 0, y power of 2 equals to 2y. So the conclusion will become like this: 2y e y2 minus 2 plus sine becomes a cos 2x, differentiate 2x becomes 2 and we bring it to the front, plus 5x equals to 5. So on the right side we need to use a product rule, that is u prime v minus u v prime. So u is x power of 2, u prime equals to 2x, v equals to ln v plus 4y, v prime equals to 1 over 3 plus 4y. We need to differentiate the 3 plus 4y times with 3 plus 4y differentiate. becomes 4. Times it with 4. And after that, we get the equation inside. 2x times v ln 3 plus 4y minus with u prime u x power of 2 times with v prime. V prime is 4 3 plus 4y. Oh, I forgot. We need to add dy per dx to the equation that have y. Minus 2 dy per dx. We can make it simpler, like we times the x power of 2 into the other equation, like it will become like this. 4x power of 2 v plus 4y dy per dx minus 2 dy per dx. Before I continue, I forgot to add the dy per dx into the equation on the front. Plus, the third step, we need to bring the dy per dx equation to the left side to separate them with other equation. This equation, we need to bring it to the right side. The next step is we need to factor the dy per dx from the equation on the left. The last thing that we need to do is we need to isolate the dy per dx on the front. Bring it to the left side, and the other equation we bring it to the right side. It will become like this. So the final answer for this question is dy per dx equals to minus 2y e power of y power of 2 minus 2 plus 4x power of 2 per 3 plus 4y minus 2 cos 2x minus 7. This is all from me. I'm gonna pass it to my group member.